Welcome back to the deep dive. Today we're looking at space weather, specifically the really intense solar activity we saw back in November of 2025. And we're trying to understand how a beautiful light show in the sky is actually a really severe threat to our entire global infrastructure.
That recent activity was a definite wake-up call.
hmm
I mean, NOAA's Space Weather Prediction Center, they issued a G4 severe watch.
G4 is pretty high up the scale.
It is. It came from an X5.1 solar flare, which is huge. But the key part is that it launched a coronal mass ejection, a CME, heading our way at something like 1,500 kilometers a second.
And the effects on the ground were just surreal. We were getting pictures of the northern lights, the aurora, from places like New York City.
The Bronx, even Cape May in New Jersey.
Exactly. So an amazing show, but what was the actual, the cost?
Well, the immediate cost was in space. NASA actually had to postpone the launch of their Mars Escapade mission.
Because of the storm.
Yeah, they cited the risk to the spacecraft's electronics. When the sun is that active, you just don't take the chance.
Okay, so let's break down the threat itself. When the sun throws a punch like that, what's the sequence of events?
Right, so it starts with the solar flare. That's just electromagnetic waves, light, so it gets here in about 8 minutes.
The first warning.
The very first. Then you get solar energetic particles, which are a radiation risk.
Okay.
But the real structural danger is the CME. That's the giant cloud of ionized gas. It can take anywhere from 18 hours to a few days to get here.
And that's what causes the geomagnetic storm.
That's the G-scale event, yes.
And we're so much more vulnerable now, aren't we? I mean, even smaller storms have caused huge problems.
Not significantly more. Just look at the 1989 Quebec storm. It was about 3 times smaller than the famous Carrington event, but it took down their entire grid.
How many people were affected?
5 million people. No power for 9 hours. All from a moderate storm.
So what's the actual mechanism? How does a storm millions of miles away physically melt a transformer on the ground?
It creates something called geomagnetically induced currents, or GICs. The CME slams into our magnetic field and makes it fluctuate wildly.
And our power grid is basically just one long wire.
Exactly. It's a massive accidental antenna. That fluctuation induces huge direct currents. We're talking over 100 amperes into the grid, and that's what melts the core of these huge transformers.
And I'm guessing it's not just the power grid. What about the internet, GPS?
All vulnerable. GICs can flow through submarine internet cables too. And we already saw a preview of this during the Gannon storm in May 2024.
That was a G5, the first in 2 decades, right?
It was, and GPS signals went haywire. In the U.S. Midwest, GPS-guided tractors just started veering off course.
I remember that. The cost was huge for farmers.
An estimated $17,000 per farm, on average. Our reliance on this stuff is a massive vulnerability.
To get a sense of the worst-case scenario, we have to look past Carrington in 1859, which set telegraph paper on fire.
We do. Carrington was intense, don't get me wrong. Aurora seen down in Colombia.
Yeah.
But the truly extreme events, like the Miyake event around 774 AD, that was on another level.
How do we even know about an event from that long ago?
Tree rings. It left a huge spike in carbon-14 isotopes. We're talking a 12% increase. Carrington produced less than 1%. These mega events seem to happen roughly every 500 years.
So we know the risk is there. We know it's immense. But if a CME is hurtling towards us, how much warning do we actually get?
Right now, not much. Our main warning comes from instruments at a place called Lagrange Point 1, or L1.
And that gives us
About 20 minutes.
20 minutes. That's almost useless if you're trying to shut down critical infrastructure.
It's not enough. And that's the whole reason for these new proposed missions, like the European Space Agency's SHIELD concept.
What's the plan there?
The idea is to park a warning satellite much, much farther out, about 15 million kilometers from Earth.
And how much time would that buy us?
It would push the warning window to around 2.5 hours.
Okay, now that's enough time to actually do something, to start powering things down safely.
It's a critical difference.
So when you pull all this together, the sheer power of a Miyake-level event, the real-world costs we're already seeing, and our current capabilities, the story here is really about a massive gap, isn't it?
The huge gap between the potential damage, which is in the trillions of dollars, and the warning time we have, which is, for now, just a few minutes.
It really is. So here's the thought we want to leave you with. If you got an alert on your phone, 2 hours warning until a potential grid and GPS shutdown, what would you do with that time? What critical data or what personal preparation would you prioritize at that very moment?